Let's take problem number 62. It says a body of mass m makes an elastic collision. That means term will remain same on the before and after, and it collides with another identical body. That means mass of this is also m at rest, and this is at rest, right? So the diagram is like this. A body, let us say this is body A, and its mass is m, and it has got some velocity. It has got some velocity. Let us say this velocity is u. It collides with another body of same mass, and it is at rest. You show that the collision is, if the collision is not head on, the bodies will go at a right angle to each other. Now, after collision, these two bodies deflect into different directions, right? Let us say, let me draw the diagram once again. I need a little bit more space. Let's say this is body A. M. Another body B is at rest and mass m. And the collision is not head-on, so that they travel in the same straight line, but they travel in different directions. Let us say one goes this way and another goes this way. Let us say this is where A goes, and say this is where B goes. And let us say this velocity V1 and this velocity is, and let us say angle is alpha and this angle is beta. The question is to establish that they go at right angle to each other. That means alpha plus beta has to be 90 degrees. Now, this may not be very difficult for you. This V1 has two components, one horizontal component, which is V1 cos alpha, and one vertical component, which is similarly V2 also has two components. One is V2 beta, another is vertical, which is V2 sine beta. V2 and beta. I think now the problem is very clear to all of you, because we have to just make two equations, one in the horizontal components, one in the vertical components. If we consider the vertical components, consider the vertical components, what we find? V1 sine alpha must be equal to V, because they are equal, and there has to be equal and opposite, because before collision there was no vertical component of the momentum. And considering the horizontal components, considering the horizontal components, we find m into u, the initial horizontal velocity. The velocity of the second body was 0, is equal to m v1 cos alpha plus m. From here we get v1 cos alpha, v1 cos alpha plus v2 cos beta. These two relations. This is relation 1 and this is relation. From these two relations, we can find out everything else. Considering the kinetic energy, during kinetic energy, what do you find? Initial kinetic energy before collision was half m u square, must be, sorry, not plus, must be equal to half m1 square plus from here we get v square plus is equal to this number 3 relation. Here are the 3 clear relations we have got. Now, I write this way, using relation 1 and relation 3. Using relation 1 and 3, what do you find? Relation 3 is relation 1 and relation 3. Relation 3 is 1 square plus v2 square. From relation 1 was v1 sine alpha plus v2 sine, v1 sine alpha. From relation 2 was 1 cos alpha. So here I have made a little wrong statement. I shall put it this way. From relation 2, from equation 2, what do we get? If we square equation 2, we get 1 square cos square alpha plus v square cos square beta plus 2 1 v2 cos alpha cos beta is equal to u square. Now this u square we use from this equation 3. U square is v1 square plus v2 square. This u square you get from equation 3. So here what do you get? If we go do transposition to left and right, here I have a v1 square, here I have v1 square cos square alpha. So v1 square multiplied by 1 minus 1 by alpha plus v2 square into 1 minus cos square beta will be equal to 2v1 v2 cos alpha cos beta. 2 cos beta. So from here we get, or V1 square. Now 1 minus cos square alpha is sin square alpha plus. Now here we have a relation that V1 sin alpha is equal to V2 sin beta. Okay, this is, I write this instead of jumping the step, V2 square sin square beta is equal to 1 V2 cos alpha cos beta. Now here we get 1 square sin square alpha plus, now this V2 square sin square beta from the relation 1 will be equal to V1 square sin square alpha. V1 square sin square alpha is equal to 2 V1 V2 cos alpha cos beta. Here we write, since V2 sin beta is equal to V1 sin alpha, that we are not mixed up later on. From here we get, I have V1 squared sin square alpha, also V1 squared sin square alpha. So 2 V1 square sin square alpha. So 2 V1 square sin square alpha is equal to, just a moment, this got a little up. So we have 1 squared sin square alpha, this plus this will be equal to 1 V2 cos alpha cos beta. Now this 2 V1 V2 cos alpha cos beta is equal to 2 V. Once again, V2 cos alpha is equal to V1 sin alpha. That we have got here. And V2 cos alpha equal to, so I write here, have seen V2 sin beta, V2 sin beta from equation 1, V2 sin beta is equal to V1 sin alpha. This we have already got. Therefore, V2 is equal to V1 sin alpha by sin beta. This relation we put here in place of V2. So 2V1 multiplied by V1 sin alpha by V1 sin alpha by sin beta multiplied by cos alpha cos beta as it was before, multiplied by cos alpha cos beta. Right? So continue with the solution. So I write once again for clarity the same thing. 1 sin square alpha, this is 2V1 square, 2V1 square, that multiplied by sin alpha cos alpha cos beta divided by sin beta. Now we clearly get that on the left hand side also it was 2v1 square. So we get clearly that 2v1 square and 2v1 square gets cancelled. And this sine alpha gets cancelled here. I am left with only sine alpha. So what is relation available with me? Sine alpha multiplied by sine beta from the right hand side. Sine alpha sine beta is equal to cos alpha cos beta. From here we get cos alpha cos beta minus sine alpha sine beta is equal to 0. From here we get cos of alpha plus beta is equal to 0, which is equal to cos of 90 degree. So alpha plus beta is equal to 90 degree. That means these bodies, when the collision was not head-on, so they did not go in the same straight line. It's like, what happens when you are playing carom. If you a dice with the striker, very often, purposefully, you avoid a head-on collision. The collision is slightly inclined so that the striker goes in one direction and the dice goes in another direction. The masses of these two bodies are same. Then the angle between them after the collision will be always 90 degrees. This, of course, you can use this knowledge when next time you are playing carom. You can always use this knowledge. So that was it. Next, we shall go to the